Okay, so with the example 1 is done. Now let's take a quick look for exercise number 1. Again, you are given a curve, which is it's a curve. It's not a straight line over here because the x is not to the power of 1. X squared minus 3 divided by x. So if we would like to find the equation of tangent line at the given point, which is 1 and at it's a 1, negative 2, then we simply have to differentiate dy dx. This is a quotient rule, alright? So yes, in a sense, you can separate it into x squared divided by x minus 3 divided by x to simply write it as x squared divided by x is going to be x, okay, minus 3 over x, and it will be easier for you to differentiate. That is why basically you have to be really competent in looking at this certain function so that you can find the easier rules to differentiate it. Otherwise, if you like to use quotient rule, it is okay, but it's going to be a bit lengthy, and a lot of people don't like lengthy working. So looking at it like this one will become a 1, this is a negative 1, so it's simply going to be plus 3 divided by x squared. So look at how easy your sum or difference rule if you know how to rewrite this function in a much simpler or separated or simplified writings. Okay, now that we have a dy dx, then finding your m is can be simply done by substituting your x, which is a 1 over here, into this function of a gradient of tangent line. Okay, so this one is like this, and then this is easily 4, and your equation of tangent of this curve at the given point will be y minus yt, and then mt. I forgot to write t over here, but if you miss to write your t, it's okay, as long as you are using the right value at the right place. If you're answering this question in the exam, then I'm just going to take a look at the values rather than the writing or notation over here, because the correct value implies that you are writing the right formula in the first place. So now this one can be rewritten as y equivalent to 4x minus 6, and that is our final answer, which is the equation of the tangent line. So this will be the last exercise for tangents, but there's a lot more resources out there. You can simply go and then check tangents, or you can actually design your own function. You can have y equivalent to any type of function, rational, logarithmic, or anything else that you know how to differentiate. So that will actually boost your confidence. If you design your own function and then you can differentiate it, you can even try with trigonometric functions, and then you can simply pick any point that you like, any x or y, and you are good to go. Okay, so you can try. There's a lot of resources out there. The books first, and then you can go and check out the internet for more on these tangents and tangents.